you're talking about polarity. So when the signal comes out, it's going to come out as a certain polarity. And when it reflects off of another material, that reflection is going to return at a certain polarity. It's either going to be the same or it's going to be a reverse. And whether the wave is speeding up or slowing down is going to decide which polarity, positive or negative, comes back to the surface and gets recorded with the GPR. So the reason I'm bringing this example up is we have a variety of polarity shifts in here. And so what you can see is that this one here is positive. This is actually negative. This is hard to see. This one's actually a positive. This one is a negative, and this one is a positive. So what we have is a variety of different behaviors, is the way that we speak about it, that the wave is going through, right? Speed up and slow down. And what you can do is evaluate those behaviors and then try to speculate on what that means. So for example, if you have a pipe, like your question suggests, and it's we're going to say plastic pipe, because if it's metal, it's not going to go through the metal. You're going to get a complete reflection just because the metal is so different than anything it's embedded in. So assume it's not metal. So if it's a plastic pipe and the plastic pipe is filled with water or the plastic pipe is filled with air, the signal that comes back, whether it's positive or negative, will be different, air versus water. Now, use the color. So instead of looking at the 1D, you're really looking at the 2D. So going to 2D, in this case, if you look at the top, we have black, then white, then black. But if you look down at this, let's say, right over here, we have sort of a white, black, and then, white again. And so those are two different, there's a polarity shift. So those are two different responses. That's because the wave in this case sped up once, slowed down in the other time. I don't know which is which, because I don't know if the wave sped up or slowed down going from asphalt into road base, right? It's going to depend on how porous was the asphalt. It's going to depend on what the size of the aggregate was in the base. And so I can't give an estimate on what happened, but in this case, we can see that obviously something different happened. And that in one case it sped up and in one case it slowed down. So what we generally do is recommend that somebody starts with a known and then moves to unknown. So if you have a concrete structure and it has steel embedded in it, it's going to mimic a slowdown, even though it's not going to actually run through the steel because it's going to be a full reflection. Based on the increase in permittivity going from concrete into the steel, it's going to mimic the same as if it slowed down. So once we have that sequence, this is how we talk about it, the color sequence, then we can use that color sequence and apply it to other responses and say, oh, here's the same sequence, looks like the wave slowed down. That pipe is probably filled with water, and there's no way it could be filled with air. I don't know if it's filled with water. It might even be just a metal pipe, filled with air, but it cannot be a plastic pipe filled with air. So that's how we do it. I think that answers the question. This is a perfect example of, again, not definitively being able to tell what's going on, but where you can apply the color schemes to the sequences to making estimations. And so in this case, you can see in the rebar up here, we have a positive, negative, positive in the rebar. We know that that's slowing down, right? Or it's going to mimic a slowdown. Okay, so here's the next question. What is this slab sitting on top of? Is it sitting on top of a moist kind of clay soil that it was built on? It's on the main floor, or is it in the basement or whatever, or is it sitting on the 4th story of an office building and it's hanging above air? Well, in this case, I can tell you for sure, it's definitely not sitting on top of wet clay, because sitting on top of wet clay is going to slow the speed down. And so it's going to mimic what we're getting from the rebar with this white, black, and white response. And so what we are seeing is instead of black, white, and black, which is the reverse, suggesting that it's sitting on top of air, or maybe it's sitting on top of dry sand. But again, I'm not a structural engineer, and I think it's probably not prudent to do that. So I suspect that in this case, we were on a 3rd or 4th or 5th or story or whatever of an office building or some other building, because we get the reverse polarity. So I don't know if it's for sure air underneath there, but it's definitely not a moist soil that's sitting underneath there. So that's how you would use polarity in these cases.